Alright, let's look at Bangalore now. It's again a 100 pointer this time, so we're back to a 100 pointer from 150 at Lagos. But that's really fine. I mean, Bangalore is a little bit easier, I want to say, but there's definitely another new concept that's kind of involved in this, so it's definitely stuff that you need to learn again. So it's a stack again, but just like Vladivostok and Lagos, it's slight twist. You should smash the stack fairly quickly. I mean, the traditional way you put in a log input, and you should be able to find out where, how long your input needs to be pretty quickly. But if you quickly look at the code, you'll see that again there's no unlock door function. There's nothing of that sort. So we pretty much always I mean, you do have the conditional locked door. There's nothing in there. You see that it's just couple of instructions. So we are gonna have to write our own. Okay, but that's something that you are now used to because you have written your own shellcode to kind of swing a door unlock, swing a door open. I'm sorry. But the twist here is that you can't just jump to shellcode like in a normal buffer overflow. You override, jump to your shellcode, run shellcode with your custom unlock door, and it'll run, it'll open up the door. That's not going to work here. Um, so I would go ahead and read a little bit about DEP, Data Execution Prevention. I want to say, I forget the full forms too much. Or NX on the Linux system, which is just a bit. It's called non-executable, but just read it a little bit. I mean, just read the wiki article, see how it works, what the purpose of it is. Just that. I mean, you'll find plenty of exploits, plenty of attacks actually exploiting all of this in real world systems. At this point of time, if you're new to all of this stuff, just don't go too deep. Just understand what it really does. Um, and let's actually quickly look at the code here just to see, just to run once and see. So we just run it once there, and you would fuzz it that way. So you send a huge input in there, and we won't break at this point. I just want to show you what happens. You see that. So you see program counter got changed to 4141, which means that you did smash the stack, and your shellcode's running, well, kind of running. But the MSP 430, or the Microcorruption, the platform on which the game is running, that sends out an error saying that you cannot execute a write only page. So that page, whatever a page is in this game, is a write only page. It means you can only write to it, but you cannot execute instructions, which means I can't jump to that. I can't run any instructions. I can't. Uh, None of my shell code, none of my custom shell code that I put into that particular page is gonna run. So I would definitely start by understanding what a page is. How a page works in this level, and how many values can a single page hold. Um, so which page did my input actually get written to? What's the current property of this page? Is it writable or executable? In this case, you can see that this page is just writable. But as you kind of reverse the entire program, you don't need to reverse the entire program. Again, all of this stuff, CTORs, input, char, get, sn, but always keep your eyes open for code that's being repeated. So you just don't go ahead and reverse everything all over again. So all you need to really reverse is these three functions. So you have mark page writable, does something here, executable, and turn on dep. These three functions are kind of key, and you have setup protection here, which basically just calls all of those in a certain order for a certain reason. Uh, I would definitely look at all of that, and again, kind of keep track of the details here. I mean, you see the SR, the stack register, you see some specific values being pushed into it, and you have other arguments depending on the function that's being called. I would just traverse all three of those functions and see exactly what values are getting pushed into stack registers, and that's going to help you while you craft your actual shellcode. Um, that's really about it. I mean, if you understand what dep does, what DEP or NX actually does, and what's the reason for systems actually having those. Think of the whole cycle. You get a buffer overflow, you jump to your shell code. You need to do something with that page before you can actually run your shell code. Uh, Compare a normal buffer overflow, what stuff happens there, and compare it to what was happening here. and there's a couple of steps in between there which kind of make sense in this level, which you need to do before you can actually exploit it. Now, once you find out what it is, then it's reasonably straightforward. I would go back and read the microcontroller, microcorruption. It keeps saying microcontroller, I don't know why. I would go back and read the microcorruption manuals one more time. That's probably going to help you a little bit as well for some stuff. It isn't super complex, isn't as complex as some of the other levels. So, yeah, all the best and good luck.